Welcome, everyone. I am Navneet Juneja, and I lead the Azure Core Compute product team. During this session, we'll focus on important capabilities that enable IT organizations to run business-critical applications on Azure. We'll provide examples and reference architectures demonstrating how you can scale your core applications on Azure without compromising performance or uptime, and rely on Azure to protect your most valuable data. There's no universal rubric that absolutely identifies a mission-critical system. The same application can be mission-critical within an industry vertical and not in others. However, there is a common thread. Mission-critical systems are the ones that support core enterprise business processes, ERP, SCM and CRM applications, e-commerce systems, systems of record like financial management, procurement and payment, analytics, and more. Depending on the industry, systems that support digital customer experiences could also be critical to the survival of the company. For example, retail. Our customers use various criteria to prioritize business-critical systems, which could include the importance of the system to revenue, company reputation, or the percentage of customers affected, for example, if a security breach were to occur. And that's why the decision process for moving these systems to the cloud often centers around things like SLAs, security, and compliance. As companies drive innovation with technology, the range of critical applications continues to expand. For example, we see organizations like JetBlue rely on Azure for traditional business-critical applications like their e-commerce site, as well as to support predictive models to improve the overall customer experience. Companies like Allscripts deliver mission-critical healthcare-related applications using open-source software on Azure. And more recently, we have seen business-critical applications that support human ingenuity during unprecedented times. Whiteboard Coordinator used our high-performance virtual machines and AI capabilities to develop COVID-19 screening tools to be used in hospitals. And this is just the tip of the iceberg. When asked about what benefits customers realize by moving their business-critical applications to the cloud, the most commonly cited were security, compliance, performance, and operational agility. Moving core business processes to the cloud enables you to make your business model more flexible and agile. You can scale up or down your IT footprint depending on several factors, including macroeconomic fluctuations and business demand. Running your business in the cloud can help you be future ready, can help you increase business resiliency, especially during uncertain times. Pooling your data from various applications in one place also unlocks silos and allows enhanced data analytics and visualization, enabling better decision making. That is also why, based on a Microsoft-sponsored research study that Forrester conducted earlier this year, 70% of companies plan to or have already moved their mission-critical systems to the cloud to better meet their infrastructure requirements. When migrating your mission-critical applications to the cloud, you will need a comprehensive platform that delivers choice and flexibility to meet your specific needs, uptime, high availability, and business continuity, security and compliance support that enable you to meet industry regulations, local laws, data sovereignty needs, and more. Scalability and performance to support increased digital transformation and more online interactions with your customers, partners, and colleagues. And cost effectiveness and operational efficiency are always important. When you run your core applications in a hybrid cloud environment, you also need tools to manage and govern your distributed environment at scale from the cloud to the edge. Across all these dimensions, Azure has unique capabilities that our customers depend on. During the session, I will focus primarily on availability, scale, performance, security, and compliance. We'll discuss the capabilities that Azure provides to meet the needs of business-critical applications, and we will do that in the context of a few common deployment patterns. The first scenario we'll look at is a scale-out end-tier application architecture built for highly available workloads like e-commerce. The second centers on the back-end engines that drive the business, applications like SAP. We'll dive into various aspects related to the deployment of these applications on Azure and ways to improve performance and scalability while meeting your SLAs. The reference architecture here will be based on SAP HANA. Third, more and more customers depend on analytics to make quick and well-informed business decisions that drive the short and long-term health of the business. In this context, we'll look at how SAP Via and Microsoft Azure can help organizations in the banking industry reduce credit risk, and a related reference architecture to support real-time decision-making with a mixed VM and container environment. This multi-tier reference architecture provides a multi-region deployment to maximize resiliency. If a regional outage affects the primary region, for example, a natural disaster, you can use Traffic Manager to fail over to the secondary region. Each Azure region is paired with another region within the same geography to enable you to meet any data residency requirements. The two virtual networks are paired to allow data replication from the primary region to the secondary one. The backend database here is SQL Server. If you are using SQL Server, we recommend SQL Always On availability groups for high availability. A single availability group that includes the SQL Server instances in both regions. If you'd rather leave this configuration and management to us, use an Azure SQL database, which provides a relational database as a PaaS offering. This architecture can also help if an individual subsystem of the application fails. Virtual machine scale sets provide the level of resiliency and scalability that the business logic tier and the web front end typically require. VMSS lets you create and manage thousands of load-balanced VMs. The number of VM instances can automatically scale up or down in response to demand or on schedule. Scale sets allow you to centrally manage, configure, and update a large number of VMs. Let's see some of its key capabilities in action. Let's look at how a mission-critical website, in this case an e-commerce store, can be configured to survive the failure of an app server, of an entire zone, and an entire region. I'll be using VM scale sets, load balancers, and a traffic manager. I've configured the site to use 4 VM scale sets, 2 in different zones in the primary region, and 2 in different zones in the secondary region. Each region has a load balancer in front of it. As you can see, each load balancer also has 2 backend pools, one for each zone. And the traffic manager is configured to route traffic to either of the 2 regions in priority order. So if the primary region goes down, it will route traffic to the secondary region. The VM scale sets are configured to automatically heal if one of the app servers becomes unhealthy. The health check here is configured to use port 80 on the app server. Let's simulate a web server crash by killing IIS. As you can see, the VM has been found to be unhealthy and will now be replaced. Of course, the website is still running just fine. And now you can see the new VM is being created to replace it. And now everything's up and we're back to 10 healthy instances. Now, let's look at what happens if a zone fails. I've deallocated the VMs in this VM scale set, so now it won't take any traffic. Now let's take down the second VM scale set in that region. So once I've done this, we'll only have VM scale sets in the secondary region that are able to take traffic. This scale set is down too. As you can see, now the traffic manager has detected that the primary region is degraded and it's routing all the traffic to the secondary one. And the website is still running. Now let's look at SAP, a well-established mission-critical application suite, and examine the benefits of running your SAP landscape on Microsoft Azure, and some of the capabilities you will likely want to leverage. This is very representative of a wide class of business-critical applications. If you're an SAP customer, you want to ensure that the provider has a great offering, but also that they have a deep understanding of the mission-critical nature of your SAP workload. In that regard, Microsoft is unique and the only cloud provider that has been running SAP for our own finance, supply chain, and HR business processes for the last 20 plus years. SAP, in turn, is running 17 of their business-critical systems on Azure, and Azure is the only public cloud where they run their internal workloads. Azure is also the preferred cloud where SAP deploys their SaaS LOBs like Commerce Cloud and SuccessFactors. Having worked with tens of thousands of SAP deployments, we understand your business needs when it comes to SAP. The Embrace initiative combines reference architectures and industry-specific journeys to simplify and accelerate your S/4 HANA move to the cloud. When deploying applications like SAP, maintaining high levels of performance for applications at scale is a common customer need. No matter how big or small your application is, Azure has a VM size for you. Our latest generation of the large MV2 sizes support up to 12 terabytes of RAM and are certified and available to our customers to run SAP HANA. Recently, we also certified our E-Series VMs for SAP HANA. We were the first cloud to introduce bare metal solutions with our SAP HANA large instances in 2016, and we've continued to expand what's possible. Last year, we announced the availability of sizes up to 24 terabytes. Customers across every industry run their largest production SAP landscapes on Azure. In fact, as a part of its digital transformation, Walgreens Boots Alliance migrated its massive scale-out SAP landscape, an estimated 100 terabytes, to Azure. SAP workloads also need high-performance storage for persistence and, in the case of NEDB, for transaction processing. Azure offers three choices for these demanding workloads: Premium SSD, UltraDisks, and Azure NetApp files. Azure UltraDisks are certified for SAP HANA and offer up to 160,000 IOPS, which makes it the fastest disk offering in the public cloud. SAP native backup using Azure Backup supports UltraDisk 2. If you're running NetApp on-premises for your SAP installation, Azure is the only cloud provider to offer Azure NetApp Files, a bare metal storage offering built by Microsoft and NetApp and offered as a first-party Azure service. It is now certified for SAP HANA VM scale-out with a standby node. Azure is the only cloud that can offer this for an N+1 scale-out, which lowers costs and enables higher availability. Let's put all that together and look at a commonly used reference architecture for SAP HANA on Azure. In this solution, the user request flows through an SAP landscape and an in-memory SAP HANA database running on Azure VMs. This system uses Linux OS clustering for high availability, premium storage for performance, data replication for high availability via HANA System Replication, HSR, and has a full disaster recovery configuration for 99.99% system availability with availability zones. Some business-critical applications can be especially sensitive to internode latency. SAP applications based on the SAP NetWeaver or SAP S4 HANA architecture are good examples. The network latency between the application tier and the database tier has a significant impact on application performance, since most of the business logic runs in the application layer. The application layer queries the database at a rate of tens of thousands of queries per second, which are often executed in 500 microseconds or less. Azure proximity placement groups are a logical grouping construct for your Azure virtual machines. When you create your VMs in the same proximity placement group, they are placed in the same data center, resulting in lower and more deterministic latency for your applications. This significantly improves the performance of the application. This last architecture design pattern is based on the deployment of SaaS Via on Azure, for example, to reduce credit risk in banking. Credit risk refers to the probability of loss due to a borrower's failure to make payments on a debt. An effective understanding of a bank's overall credit risk is critical to avoid defaults, to manage rates and reserves, and to defend scrutiny from regulators and investors. One way for banks to achieve better credit risk management is to use machine learning for underwriting and origination of new loans, and for predicting loan delinquencies and defaults, and projecting potential losses. A systems administrator creates SAS9 and SAS Via software container images that are committed to a container repository. They can then be launched on demand with AKS by a risk model developer. In addition, a massively parallel instance of SAS Via is deployed using virtual machines. Because analytic workloads can be very diverse, different types of ML compute patterns can be run on different interconnected compute architectures. A risk model developer logs in with their AD credentials using the Azure AD instance for authentication and authorization. All SAS compute engines can access shared data in parallel across different Azure data sources. These connectors are designed and optimized specifically for Azure. Different types of SAS compute engines can seamlessly communicate with each other. A risk model developer can choose to run individual container instances of SAS to support ad hoc model development, or run massively parallel in-memory algorithms on large datasets. The MPP instance will also support low or no-code visual modeling applications, as well as collaboration across models, pipelines, data, or other mission-critical objects. Once a model is developed, the model and score code is packaged and deployed into operational systems, made executable in a container, or called through APIs. Models are monitored for performance, tuned, and redeployed using visual interfaces or through automated processes. In some cases, certain ML workloads can benefit from more specific architectures. For example, to take advantage of GPUs for SAS deep learning, or to process transient streaming data. This slide shows a variation of how SAS Via would support multiple in-memory CAS engines, each tailored to specific workloads on Azure VMs. This automatic synchronicity between model development and model deployment helps banks achieve their mission by enabling the best credit risk decision every time. We are seeing more and more customers realize that taking advantage of Microsoft's deep investment in security far outstrips what they could do on their own. Azure supports more than 60 regions around the world and offers the fastest and most resilient global network in the public cloud with more than 170 edge sites. We're the only cloud provider that enables customers to extend private connectivity to remote or hard-to-reach areas with ExpressRoute satellite. Azure also enables on-prem to on-prem connectivity across our global WAN with ExpressRoute Global Reach. We invest heavily in security, and we have 91 compliance offerings. Azure Security enables defense in depth and simplifies security management with built-in controls and services and integrated partner solutions. These solutions enable you to quickly enhance protection for your Azure workloads. You can ensure confidentiality and integrity of data by leveraging multiple encryption options for data at rest in virtual machines, in databases, and in storage. Azure Key Vault enables you to safeguard and control access to cryptographic keys and other secrets used by cloud apps and services. Azure Virtual Networks, Network Security Groups, VPN, and ExpressRoute enable secure connectivity to and within Azure, and you can protect against network layer threats with services like Web Application Firewall, Azure Firewall, and Azure DDoS protection. It's important to assess your security posture continuously. Azure Security Center helps you monitor the security state of Azure resources and hybrid workloads. It offers a centralized security console that offers a dynamic security scorecard and recommendations to improve security across all your resources. Advanced threat protection backed by Microsoft Intelligent Graph enables you to detect and quickly respond to threats across Azure. Azure also offers a robust log management system and insights from log analytics. You can further extend the security capabilities of Azure with a rich array of products built specifically for the Azure platform. The Azure Marketplace includes partner solutions for anti-malware, network security, encryption, monitoring and alerting, application security, authentication, and more. Identity is at the core of security. With Azure's Active Directory, you can federate to your on-premises Active Directory and offer seamless single sign-on with multi-factor authentication for all your applications, whether they are on-premises, on Azure, or a SaaS application. Azure AD has connectors to hundreds of applications, ensuring that your users can seamlessly log on to all their core enterprise applications without having to manage multiple passwords, boosting productivity and security. In recent months, with so many more employees working from home, customers have relied on Azure Active Directory to safeguard access to systems and data. Some of our customers may need to address corporate or regulatory compliance needs, such as those that require host-level isolation or a dedicated physical server for a workload. They meet these needs using Azure Dedicated Host, which enables you to run your Linux and Windows virtual machines on a single-tenant physical servers. Some customers also want absolute control over when host maintenance may happen for a particular VM or workload, even when that maintenance event is considered non-interrupting. Dedicated hosts give them the ability to have a high degree of control over maintenance. With mission and business critical applications, availability and resiliency can directly translate to the resiliency of your business. When you look at the infrastructure layer on Azure, you can take advantage of increasing levels of reliability and protect against single host failures, hardware failures, for example, at the rack level, entire data centers going down, or even protect against impact from natural disasters with industry-leading RPO and RTO. However, beyond infrastructure failures, you also need to protect against data failures, particularly with issues that sometimes surface some time after the event that caused them, like data corruption. Access to a robust set of backup capabilities is very important, and Azure provides that both directly and in conjunction with our partners. In some cases, you may need control over all maintenance of the underlying host for a specific workload. This need was addressed with the recent general availability of the ability for customers to control the maintenance of dedicated hosts and isolated VMs. We are now introducing two new capabilities that let our customers increase control over maintenance operations. Azure customers will now be able to declaratively specify a maintenance window schedule for their resources. We are also adding the ability for customers to use the same approach to control when guest OS image updates on virtual machine scale sets should be rolled out when using the VMSS Auto OS update capability. These new capabilities further simplify the management of business-critical applications on Azure while helping IT administrators improve the security posture and availability of their environments. These new capabilities are offered at no additional charge. We've covered quite a bit of ground today, and many of you are likely now wondering how you can easily take advantage of Azure's capabilities and accelerate your cloud migration. A resource many of you might find useful is the Azure Well-Architected Framework, which distills the best practices and architectural guidance you can follow to increase the performance, reliability, security, efficiency, and cost effectiveness of your cloud environment. With this comprehensive framework that will continue to evolve, you can more confidently transition your workloads to the cloud using architectural blueprints like the ones we discussed today. Let me leave you with some useful resources. A webpage that features content regarding the deployment of business-critical applications such as SAP on Azure, and more information about the Azure building blocks our customers use every day. Thank you so much for joining us today.